We're going to start now. Hello, everybody. Thanks for coming. Thanks for joining us today. This is a CASME workshop or a CASME panel on the thing that you have to talk about nowadays, and that is generative language models, and in particular the chat family. It's when a piece of technology becomes the piece of technology that has the fastest rate of adoption of any piece of technology in history, and it's in your space, you really have to have a conversation about it. So the conversation today, though, is because of the nature of CASME, where CASME at CASME, we're concerned with issues of safety. That is, when we have new technologies, how do we actually look at them from the point of view of safety and harm? We wanted to have a little bit of a discussion about the harm and the benefits of generative models, and really start to think about where they are and what impact they're having. I think particularly when the Future of Life people put together a document that many honchos in the field have signed about slowing down the work on generative models. It's really time to look at this from the point of view of what people are using them for and what issues are they confronting. We put together a panel today that is really aimed at giving us very different points of view, and the panel, I think you'll find exciting. First off, from Northwestern is Jessica Holman. Jessica Holman is the Ginny Rometty Associate Professor of Computer Science here, and works in the area of visualization, and in particular works on problems having to do with people's human models of what these visualizations mean, and how the model itself, the human model itself of what they are seeing, impacts how they are interpreting things, and how we can make sure that interpretation actually hews to the truth. It's not just that the image, the visualization has to be correct, but our understanding of what that visualization has to be correct. And so we're going to talk about, her life is people not understanding things, and how to fix that. We also have David Leake, who's with us from Indiana. David is one of the forerunners in case-based reasoning, but I think he is here primarily because we wanted to have a semanticist who could talk about the relationship between semantic information processing and the kinds of systems that we're seeing in the generative space now, and what is the relationship. And then Ben Lorca, who is coming at us not from the academic side, but from industry, and in fact from the point of view of someone who is actually advising and helping to guide the adoption of technologies over the past a couple decades now. That is, Ben's the editor of the editor and functionally the owner of the Gradient Flow newsletter, and has actually lived a life of working with companies who are struggling with trying to understand what these technologies are and what they mean, and helping them to get the right model in place, so they don't either fall behind or race so far forward with bad technologies that they damage themselves. And I want to thank all three of them for being here today. We are excited about this. And I just want to start off by really asking. I'm going to start off with Ben, and really asking the question of really what right now is he seeing as the opportunities that are in front of us, and in fact, what opportunities are companies seeing as they are looking at this technology. And if we just start there, I want to start on the very much on the positive side. Ben, I'm gonna hand it to you. Ben, you're muted.
So as Chris mentioned, I'm coming at this mostly from the Silicon Valley side. I'm now advising a bunch of startups. I've invested in several new startups actually over just the last few months in the space. But with that said, I also advised the first law firm focused on AI and analytic safety. So I kind of have worn both hats. So in terms of what's exciting, so I think one is that as many people know, it seems like the utility of the technology, especially with the release of ChatGPT, just caught the world by storm. So I think there's a wide range of use cases. There's already a bunch of companies generating a lot of revenue, startups, ranging from, copywriting applications, right, targeted at marketing teams and copywriters, to developer tools, right? So those are the classic examples. And then to some extent, graphic design. So in many of these cases, these use cases, it seems like the model is not necessarily to eliminate people's work, but basically make people much more productive, at least at this point, right? So for example, I use a lot of the developer tools and for coding and programming, and it just, so the approach to doing that kind of work has changed for a lot of people. So before, you would probably look at something, you go, this will take me 24 hours to figure out. Now it might take you 2 hours, right? So but you still have to do the work, right? So these systems generate answers that you still need to inspect and test and use, right? So and then the other aspect of this is that it's much more accessible to a lot more users. So in fact, I would say that one of the trends right now, set aside the actual users of the tools, but in terms of the technologies themselves, I think one of the big things that we'll see right away shortly is that this set of technologies has now gone, Chris, from the province of data and AI teams to now just regular developers, right? So I make that distinction because the regular developers may not be as steeped into the processes that ML teams may have, right? So they're just users of these tools and technology, so they tend to move faster. So think of the cohort of developers who follow things on Product Hunt. I don't know to what extent the audience is familiar with Product Hunt, but Product Hunt is the site where product teams and developers release new products, features, right? So these are people who iterate and move fast. So these technologies are now available to that cohort of teams, right? So I expect many more use cases, and with that, of course, comes great responsibility, and a lot of these new teams that are now starting to use these technologies may not be as steeped and familiar with the things that AI teams, who may not do it as well as some people expect, but at least they have notions of checking for safety, alignment, right? So they have some basic processes in place. Now we're opening up these tools to a new cohort of technologists, right? So basically the same group of people who are comfortable piecing together APIs.
Awesome, thanks. I mean, Jessica, so I mean, so we got this massive adoption. People are pulling the technology, the technology or technologies into play to generate a lot of content. And the question for you is, as you've looked at the world of visualization, and you turn your eye to looking at the content that's being generated. I mean, it seems like there are the model of what is going on there, that is what they're doing, it seems to be crucial. And I mean, what do you see as like sort of the primary issues in terms of people utilizing this, just from the point of view of them understanding what it is?
Yeah, I mean, I think, so I would first say I do a lot of research on visualization, but even more so my research is kind of about uncertainty in data-driven science. And a lot of it has looked at things like how do we, just communicate uncertainty even in research. So kind of, I'm interested in sort of, when we're learning something from data, how do we then communicate the limits to inference or prediction from that? And so I think, I've looked a lot at things like large language models, and I am very interested in sort of how people understand these things. And I think that where they're really interesting to me is as they relate to sort of, understanding uncertainty and like linguistic utterances. So, we know from just like reasoning under uncertainty studied across different fields, economics, decision making, that, people have some issues with uncertainty. So as like speakers, we often, are incentivized to speak overconfidently about certain things. So, if you look at how, scientists present their work, we're often kind of like suppressing the uncertainty, and some level like language is about making these kind of, assertions. Like it's hard to say nothing with language we're trying to communicate. And so we're communicating sort of propositions. So people tend to be kind of overconfident when they speak, but also when we interpret information, we tend to sort of avoid uncertainty, just because it's hard to know what to do with, especially in a data context. But I think also in a context where, you have some model, producing something for you to look at or for you to read, we don't know what to do with uncertainty. And so we might be over trusting. And we know that people are over trusting of AI in some ways. And so I think, we need to know, the truth content of different statements. It's essential to communication. Like Grice's maxim of quality says that we have to be truthful about what we know to communicate. And so I think with some of these large language models, what the sort of big problem is that they don't necessarily know what they know. And so when we're using generative models to create text, for instance, they can sort of dazzle us by appearing to like, be human-like in various ways. So, large language models are essentially just predicting the next word in the sequence one at a time, but then they can, emit behaviors that make us think that they're learning sort of representations that are more human-like. So, if you ask them to generate poetry, et cetera, you can be really surprised at like how well they seem to encapsulate like different patterns. And so I think, there's sort of this difficulty that I worry about with people, not knowing, or not questioning enough the content that they're getting. One of the major issues, related again to uncertainty is that we know that, while these deep models, for instance, will have internal kind of confidence scores that give them a sense of like what's most likely, they're not often well calibrated. So they have, these like pseudo probabilities that tell them, like how likely is this to be the next word in the sequence. Those probabilities are not really an accurate description of sort of how good that next word is. And so, one of the problems is that can also translate to like, large language models trying to express their confidence in what they're saying. So there's some research, that tells us like, when a large language model tries to, when you ask it how much it knows or the limits of its knowledge, like it's not very good at telling you that. There's some like promising aspects as well, though. Like there's researchers who are sort of looking at ways that you can sort of get better calibration by training language models in various ways, so that when they say they're like, almost certain of something, they're actually, likely to have like a 90% probability that they're being correct in that case. But there's also, I think, this whole other issue that, concerns me in particular, which is that, at the same time, like we can try to fix some of these issues, but like a lot of these large models, whenever they're being trained to sort of, produce output that a human judge says is high quality, they can learn kind of like they can learn sort of what a human sees as like convincing. And so we see this in some of the language cases in particular where, like a human, like they're trained on, large scale text generated by humans, and humans, when they want to convince someone, that maybe they're right, even though like maybe they're kind of bullshitting, a human will say things like, well, this is really sort of subjective, or, like you can gaslight the person you're talking to, saying like, well, that's not really what I meant, even though you just said something and they're properly interpreting it. You can say things like, oh, there's really no right answer. There's no right and wrong clear answer in this case. And so one of the things that's kind of creepy is that, you can see like large language models starting to emulate this. So they're trying to convince, you're having like a dialogue with a chat GPT, and it says something that you really question. And so you ask it like, are you sure about that, blah, blah, blah. And you can get some of these like, kind of like, it's been called like emergent deception, where, it's almost as though the model, has some sense of a theory of mind of how to convince you as a human. And so I think that, understanding how to go forward with research, knowing like we need a good sense of what these issues are, and then how do we, try to avoid them. So yeah, I think, when it comes to sort of like the truths of the things that are being generated, like we really have to think carefully about how do we make sure that humans are in the right place to judge and to recognize when something that's being put in front of them is actually kind of skeptical or suspicious. So I'll stop there.
All right. One of the comments that people have made over and over is that they in general, they sound incredibly confident.
Mm-hmm.
And it's like,
People
well, that's
sound
because
confident, right? Yeah.
People sound confident, and they're emulating.
Mm-hmm.
And it's like, of course they sound confident. I mean, who in the world produces documents and puts them out in the world saying things like, well, I'm not sure, it's not clear, I haven't. I mean, the preponderance of documents are like clear as a bell in terms of tone. So David, it's interesting, David. You come from the same background I come from. That is a sort of hardcore semantic natural language understanding and generation. And how do you? As you're looking at this technology, where we were living in a world where the very explicit representations, very explicit notion of trying to conform to ground truth. As you look at these technologies emerge, how do you feel about how that relationship can be, what that relationship really looks like?
That's a great question, because it really gets to the heart of what large language models are and can do, and basically where AI needs to go from there, at least I would argue. And so I'd probably answer that in three parts. One is just the fundamental nature of ChatGPT, basically what that means, or similar systems, and what that means for the in principle capabilities of these systems. And then looking at what one would need to go beyond those to really a semantics-based type of system. And as I think Jessica mentioned before, there's kind of implicit in a lot of commentaries that large language models like ChatGPT could provide a general mechanism for intelligence. When you see text that looks so human-like, it's very compelling and kind of easy to be lulled into the idea that it's actually understanding. Of course, people know that there are errors, there are hallucinations, etc. But a common view, because the models have become increasingly good as they become larger, is that basically just bigger models and more training is the answer. But it's really a much more fundamental problem than that, because the language models are statistical models of language usage and fluency based on training. They can say the sorts of things that statistical models can say, basically, what are the odds of something? And so the odds are the answer is this. And then from that, it's possible to glue together things that look very human-like, but also with fundamental gaps. And there's actually an example. And yesterday, I was with a friend playing with Bard, and we had a poem that someone we knew had written, and decided to ask Bard to analyze it. And so gave it the poem with the title and the person who wrote it. And Bard came back with a very nice analysis of each one of the verses, but started it out by saying, this poem by, and actually gave a different author for the poem than the one we had given. And it turned out the reason was that there was a famous poet who had written a poem with a similar title, And so the odds were much more likely that the author would be the person in its training data rather than this unknown that we had given it. And this is a sort of error that a human would never make. So the question is kind of what is the system really doing? It is just trying to find patterns. It's really good at getting language that will express ideas and potential facts, but it's not at all intended to go beyond these or to generate the ideas themselves. And so it can't capture things like facts reliably. It'll come up with things that might seem statistically likely, but in different contexts, it could actually make other assertions. Doesn't capture causality. Again, it can capture some patterns which may or may not actually reflect the causality of the world. It can capture likely alternatives in reasoning, but can't come to definitive conclusions. Can't capture ephemera. Basically, the training is very expensive, and so the models tend to get frozen. Doesn't have capability to learn long-term memories or to explain the provenance, why it actually has come up with a particular conclusion. And there are people who are trying to address this in kind of a piecemeal fashion for things like provenance. But the big issue really is that what it's doing is looking at language in isolation. And the alternative view, kind of semantics-based view, theory of language that was actually proposed by Schenck like 50 years ago, or almost 50 years, is just that language is communication. And so the model is that what human language is you have ideas from which language is generated, from which meaning can be extracted, and that gives understanding. And this is a process that arises from the needs of agents that have goals and plans in the physical world or in their mental world, and are trying to actually communicate in order to serve those goals. And so the alternative to the pure isolated language model, the semantics-based system, would be one that actually had semantic components that could drive these models, that could basically provide things like facts, reason about causality, capture and relay relevant information, make inferences, and remember. These could be augmented with actually data analysis. You don't have to give up the data in order to have these systems. But the idea would be to actually understand what the user wants to know and kind of do a negotiation between what the user wants to know and a model of what the LLMs can actually answer, how to ask, and then to support and explain to the user what the responses are. And so basically, I see these systems as a great opportunity, but we really do need semantic models that reflect that language is for communication to drive these models in order to enable the behaviors that are really essential that can't be achieved by statistics alone.
So, Ben, so I mean, one of the concerns is that people will be looking at these models as somehow almost as having knowledge at the level of human knowledge, or even knowledge at the level of a search engine. I mean, when you're looking at what people are doing, particularly startups, what functional role are the generative models playing in the products that they're building?
So there's a couple of trends I want to point out. One is I think right now the prevailing approach or assumption is there will only be a handful of this LLMs or foundation models. But I think increasingly it's become clear that people are probably going to build custom foundation models for a variety of reasons, right? So either they are not comfortable shipping data through an API, maybe there's regulatory reasons, maybe they want to move faster than the API even, right? So they want more control. So that's one trend that I'm seeing, is that there are people building tools to help companies build custom foundation models. And that could mean either just fine-tuning some open source artifact or actually building something from scratch. And then the other trend I'm seeing is that people understand that this is just one an application that uses this needs external resources, right? So it could be a vector database or a knowledge graph. So people are experimenting with kind of this hybrid information retrieval, neural search kind of approach. And also it could be plugging into external services, right? So last week or 2 weeks ago, OpenAI released their plugin interface, right? So now you can integrate with all sorts of web services, Shopify, Wolfram Alpha, and so on and so forth. And then it turns out it's actually dead simple to build these plugins for these LLMs. And then finally, there's startups and open source projects building abstraction tools so that you can plug in different LLMs on the back end, right? So for example, you may have an LLM that's pretty good at one thing and another one and another thing. So you don't want your code to be completely dependent on the particular LLM, right? So there's a lot of developer tools that are emerging. We're still in the early days. There's a lot of integrations, but I think one thing that people need to assume moving forward is that there's going to be demand for organizations and companies who are interested in building custom models. And then, to David's point, I think, so the scaling laws seem right now quite clear, right? So the larger the model, the more effective it is. But people are also somewhat hopeful because there's some examples in recent large language models that say that maybe you get a certain size and then you just need to saturate the training, have more data, and then you get a model that's comparable than the ginormous model, which, by the way, is quite funny because now we consider 7 billion to 10 billion parameter models small models.
To be modest.
So because the benchmark now is in the several hundred billion or trillion parameters, right? So, but there's a lot of hope in this range of several hundred million to 10, 20 billion parameter models that if you customize and really feed your data set, your domain specific data will be as good as some of these, because companies are not aspiring to be search engines or general purpose Q&A tools like ChatGPT or Bard, right? So custom models and rise of developer tools that make it easy for people to build.
I'm going to stay with you for one more question here. That is, when you're looking at, you're talking to a lot of people, and I'm not talking about the companies you've invested in, but have you run into companies where they clearly just have their models are their model of what they're looking at is just wrong? Or is there an awareness that what we're looking at are things that are more fluency engines than information systems? I mean, what do you see? What do you see in terms of the model that companies have around these technologies?
So I think in general, I think maybe there's a bit of irrational exuberance, obviously, right? So I hear a lot from the teams inside these companies who complain to me that basically some higher up now complains that, whatever project that we budgeted for, let's just abandon that because in light of ChatGPT, let's just drop your old project and then just pivot completely to this, right? So there's a lot of that, I think, happening right now. So let's say you had budgeted for this year some IT or ML project, and now it's being questioned. So I think there's a lot of that going on in companies at the moment, and it's because I think as Jessica and David point out, I think the people who interact with the systems get carried away, right? So, and they tend to be maybe more in the decision-making level rather than the actual teams who are in charge of actually delivering these systems.
I'll add that
That's
actually on the
okay.
cognitive science side, there also I've seen irrational exuberance in terms of these models. I'm thinking these models are going to transform our picture of intelligence and not realizing the limitations and kind of what in principle they can capture and what they can.
I mean, there is this argument that, you just, bigger will be better. And there'll be convergence on artificial general intelligence. But there is this sort of other idea, and this is that what we're going to get is something that a set of technologies that are incredibly good at doing what they do, but what they do is not the general intelligence. It's something else.
Chris, the only thing is, I would say the clear contrast here is Web3 and crypto, right? So, which there was a lot of irrational exuberance out here, but then the use cases never emerged.
Yeah.
Here, it seems like at least there's some use cases, right? So early.
No, that's the thing that, I mean, it seems like that there was a rapid movement towards use cases that actually made a lot of sense.
And
Actually,
I apologize to all the crypto fans in the audience.
No, it's and no, it was for crypto. I recall talking to an investor saying, yeah, we have a massive amount in this where we tend to be investing in platforms because no one can figure out what the specific use cases really are. It was like,
and
yeah.
In this case, you already have companies with millions of dollars in revenue based on this stuff, right? So.
Oh yeah. I mean, but the thing that for me the concern I would have has to do again with the people's model of this, and I'm reminded oddly enough of the very early days of movies, where it would be we didn't have movie theaters, we didn't have movie houses, we didn't have anything except there'd be a projector and there'd be a screen put someplace, and you'd sit down and you'd see a movie. But one of the first movies was a train coming at you. And people would stand and move away because their model of it was the only model they had of images that were moving were real things, and our only model of real language use at the level of I would say from actually from the early days of GPT on. Our only model is humans, and so we imbue the systems with the kind of mentality that we would associate with humans. And the question for me really is, and this is I'm going to go back to you, Jessica, is how do we control for that? How do we make sure that it's not that every CEO thinks that it's got the smartest box in the world in its office now, and all development has to go in that direction? Because they've misunderstood what it is. I mean, how do we actually control for that? Or how can we?
I think that's a great question. Yeah, I mean, I think it's hard, as someone who, just believes very much in sort of the critiques like people like Judeo-Pearl make, about like there's no causal reasoning in these kinds of models. Like it's a little hard for me to say like how much can we impart to like the average user in industry of these models. I mean, I think there's certain aspects of the rhetoric which we could just try to avoid, and certain speakers like Gary Marcus and people like Ben Schneiderman have various talking points that I would say I agree with, in terms of like you can sort of, I don't think you can stop people from wanting to use these things or being fascinated with them. I think there's this like uncanny human resemblance that people are just fascinated by. But I do think, being clear about what they can't do is important. So, like I said, I don't know the extent to which you can really get people to understand, but I think people can understand sort of the difference between mimicry and having some sort of internal model. And so I think, better like journalists in particular are in a good position, I think, to just be careful of making statements about intelligence, for instance, that sort of reach too far. I think the whole notion of like general intelligence is very sort of misleading and confusing, because I think when we use that term, we have this very narrow sense of intelligence in mind, even like why is intelligence have to be sort of this single agent? Like people are intelligent through collaborations, et cetera. Like, how do we, there's just a whole host of problems when we start trying to, define what is intelligence. And so I think like people like journalists, again, people who are kind of in these positions of talking about these models, there are certain talking points perhaps that they could be prepped with. And I think, like I said, certain speakers like, or, people with strong opinions in the space, Ben Schneiderman, Gary Marcus, are making kind of these, clear guide, or trying to give clear suggestions to people. Another one is sort of this idea that these LLMs can be like sort of teammates or like equal partners in collaboration, I think is something that, avoiding that kind of framing could be helpful for just sort of general public sense of what these models can do, because like ultimately, they can't take responsibility for their actions. And so when we talk about them as sort of like these, agents who are like equivalently intelligent and equivalently sort of capable of, collaborating with us like another human, I think that sort of overlooks these fundamental limitations as well. But yeah, I mean, some of them, I think we're still figuring out maybe how do you control sort of the expectations that people have about these models. I mean, I think like one of the best things is honestly, like the more people experiment with them, they are very impressive, but for me personally, like it didn't take long for me to be like, like you can get a pretty clear sense of sort of the limitations just from asking something like ChatGPT a few questions. And so, I think we have to, not try to sort of withhold information from them, but really just be a little more strategic in how we talk to sort of broader audiences about these things. So that's my.
By the way, one trend, Chris, another trend in companies is now companies are aware that employees are putting all sorts of proprietary information inside these systems, right? So
that would be the other question. So I mean, it's just like in the early days of Google. I mean, you'd type in your query and you'd get some results and you'd click on the fifth thing that you were given. And Google was collecting that data and using it to improve the engine. And when you are working with chat and you're typing things in, you're improving the engine because they're collecting data. And it's like, what is the?
But hopefully, it's not something that will drive the next earnings call, right? So.
Yeah, that's the thing. Is that even though there's a OpenAI is open about it. But there's people almost immediately forget that what they're that what they're doing is sharing what could be privileged information and certainly proprietary.
No, that's what reminded me when Jessica was saying, right? People forget what they're typing into.
Yeah. I mean that's a huge issue. So recently, there was the Future of Life people, and some honchos decided to put out a call for a moratorium on further development of these models, with the idea that they're moving so quickly we don't know how to respond to them. And actually, I'll give it to all three of you. What's your take on that kind of notion with regard to this technology? Should we just stop for a minute and sort of relax until we figure out what to do next? I'll give it to you.
Is it realistic to? I mean, first of all, you've got geopolitical considerations, right? So, Chris, you know that I've spent several years organizing AI conferences in China. So there's that, and then there's competitive pressure, and then I just don't know that it's realistic to have people stop. So if it's not realistic, what can you do that achieves the same goal instead of stopping? So I've been thinking a lot, Chris. I don't know if you're familiar with this thing from the Federal Reserve Board, SR 11-7, for guidance and model risk management for banks, right? So so this is a regulator, and this guidance, if you're a bank, you have to follow it. But I don't know, there's no equivalent for that in AI, obviously, because it's a general purpose horizontal not domain specific. But the reason that I bring that up is in banks, it's a very different situation because basically you've got this guidance from your regulator. So then you have to take it seriously. Then what that means is that the people who are the risk managers are sit in a different team from the model builders, right? And then they're empowered, right? So it's not like these people have more resources and more influence, right? So the model builders, the risk managers have influence and resources as well, but they don't sit in the same team. But that's specified by this SR 11-7. I don't think that's going to happen in AI, but short of that, I don't even know if this sort of risk management best practices would have happened in banks, short of having this guidance from the Federal Reserve Board, right? So without that, even financial services would not have these good practices like red teaming and all of these things, right? So, but in AI, we don't have a regulator, so I don't know what the answer. I don't have any answers here, people.
I'm thinking about in the European
Go.
in the European Union, of course, there's the right to explanation for decisions that are made by automated systems. And it seems that if for applications of large language models, there were some similar, at least in some cases, right to explanation, or if there were a push for providing capabilities, not even necessarily to explain why the model decided it, but to explain why the decision makes sense or doesn't make sense, or what the potentially relevant information is, that could go a long way to mitigating at least some of the risks.
They can, I mean, they can do that now, honestly, but I guess you have to encourage them to do it. But yeah, I'm not sure if that gets us all the way to even what's the situation is in financial services, just providing an explanation, because they have that too, but they have much more, right? So.
Right. That is, you can ask them for an explanation, but whether that is, I guess, the explanation that they provide would be again based on the statistical information rather than potentially on, say, a causal model or something more reliable. So their explanations might not be enough.
Yeah.
Type up to say that there's some interesting research in just the limitations of some of these common like explanation and interpretability methods, where there's been like a huge push in like, certain areas of CS research towards different ways to generate explanations or saliency maps, like for computer vision models that tell you what it's looking at. And what's sort of, a little bit just concerning is that, many of these explanation approaches themselves can be sort of attacked, where you can mess with the model's internals, and you would expect them to see the explanations change because the model's, no longer working the same way. And that's not often the case. And so a lot of this, I think there's just this fundamentally hard problem of like, we as researchers still don't fully understand how they work with some of these kind of, like the internal representations, and how to align the questions we have with like, what's the model actually seems to know and doesn't know is, I would actually amend my answer to the last question to say in particular, like one thing that could, be useful just in the whole conversation about these models is for, the people working on them to just be a little more upfront about like, the limits of our own knowledge of sort of how these things are learning and the kind of internal representations they're creating. Like, I think we tend to act as though, yeah, we can explain, we can get them to generate explanations, et cetera. And I think that's part of the problem, is the idea that it's that easy.
Mm-hmm. Exactly. And I think that one thing that's very important, I mean, there's been an argument between whether one should try to add explanation capabilities to black box models versus go to interpretable models. And I think there are a lot of compelling arguments for going to the interpretable models. And so if one were to actually leverage language models in something like a symbolic AI system that actually was interpretable, I think that would have a lot of benefits for at least being able to assess the results and potentially trust them.
Yeah, I was going to add one thing to Chris's question. You had posed the question to all of us about this letter shut it down. And I mean, I was just gonna make a few comments. One, I think that I don't know quite what to do with it, but I am aware that like historically, like, you know, when there's a new technology, there's often a fear of it, sort of a, you know, like railroads and, you know, the production line when it was first introduced. Like, I think it's useful maybe to maintain a little bit of perspective. Like we often, and maybe there's good reasons we fear new technologies, but I agree with Ben that it's not realistic to think that we can shut these things down. I do think, like, for me personally, I don't know in terms of regulation or how you would actually address this, but the idea, like right now, a lot of these large language models, for instance, are just kind of these, you know, chat assistants. Like you can talk to them, but they can't actually act in the world in any real way other than by like impressing their beliefs on us. And so I think like one of the things that worries me is some of the sort of scenarios you can imagine as being like, you know, pretty plausible if these models also can act in the world. So going back to the idea that they can like learn to deceive people, you know, if a model knows what a human is convinced by, like when you're trying to argue with a human that something is factual, you know, you might like point to Wikipedia or whatever. And so if you imagine a world in which these models, you know, can not just like generate content, but can also not just generate, I guess, linguistic content or imagery, but can also, you know, have a wider range of actions that they can do. Like if they can go online and just create websites or, you know, post a new Wikipedia page, I think, you know, that kind of thing I could see, you know, being more concerned about. I think that maybe there's some sort of regulation that needs to happen, but I'm not, I don't know enough about policy to suggest what that would be, but I do feel like there's
That
Yeah,
is a combination of a brilliant idea and one of the most malicious. I love the notion that you have an argument. I mean, you've got the APIs out there, so you have an argument with a language model, and it builds a website.
It generates like 50 fake websites. Exactly.
I think
Yeah.
that's brilliant.
Yeah.
I'm sorry, Ben, go ahead.
Yeah.
By the way, so there is the EU AI Act, but it's a bit delayed and confusing, and yeah, I don't really know what to make of it. The NIST, National Institute of Standards and Technology, has issued a AI risk management framework that I think people can use as a starting point. And I think, you know, if when I talk to the law firm that I advise that specializes on this, you know, their main advice, if there's only one thing you can do, is improve the heck out of your documentation, right? So how you build the models and data sources. And I mean, at a minimum, everyone should be doing that. And as I point out, in financial services, because of this SR 11-7, they have practices that maybe people can learn from, right? So like this kind of having an independent risk management team compared to the people building the models. I don't know how that's going to fly in many companies. I'm sure the people building the models will have resources which is like 500x compared to the people checking on alignment and safety, right? So, but if somehow there's a little bit of parity there, maybe that can help. And there's an independence on the people doing the safety and alignment, that might help. I mean, none of this is are 100% answers, right? So, but we're still kind of learning a lot as we go. But I think one thing that is clear is that people want to move with these technologies. So how do you do that as safely as possible? That's a challenge, right? So they want to adopt it, they want to deploy it. So if you're a company, I think at the minimum, it's really worth trying to understand what are the best practices around alignment and safety. How can we bring that in early? How can we resource these teams and give them independence? But, you know, I mean, as you folks know, big tech has struggled with this, right? So, I mean, they've had these teams and they've dismantled these teams, then they bring it back, then they dismantle it again. So it's a tricky problem.
Yeah, I mean, for me, one of the trickiest parts is that when you think about the technology and then you think about the deployment, you end up with you could have very different scenarios with regard to one technology, where in one instance, the deployment is absolutely appropriate to the technology. And in another, it's inappropriate for the technology. And in the latter case, you're going to have something that it has more of a potential to cause harm. So, if I have a language model and I'm using it to actually articulate a set of facts that I can guarantee, that's very different than a language model that I'm using to actually see if those, to find out about those facts. In one case, you've got control over the knowledge. In the other case, you're hoping for the best. And that's for me, it's like managing that kind of risk seems, and even within an organization, seems unbelievably difficult in terms of how to create a regulatory environment around that. I think that's a genuine issue. I mean, as people are sort of thinking about this, Ben, sort of, you mentioned that there was this quasi-monopolistic moment where it looked like the only people who were going to have foundation models were going to be the super large companies. But it seems like there's more and more of a push towards smaller models, less expensive models that are specialized. And then the question for me becomes, well, once you've got, what are either best practice or regulatory notions that can actually help with that level of specialization? Because that means that everyone has to know how to do it, as opposed to a few.
Yeah. So that's the challenge, right? So now people are starting to see that, hey, building custom models seems like within reach, right? So not for everyone, obviously, not everyone will do it. Some companies won't have the resources even to build these customized models, but for those who do, then with all that power comes responsibility. So they'll need to staff up on the alignment and safety side as well somehow. But I don't think those considerations are happening right now. People are just thinking about, let's figure out how we can build these custom models, or what tools can we use, what startups can help us build these custom models, and then we'll. At least I haven't detected much conversation around what happens after we do the custom models. I mean, the other consideration, of course, as you folks know, is that deployment of these models is also challenging because the inference is expensive. I mean, every time you query ChatGPT, that's a lot of GPUs. Let's put it that way. So then a lot of companies are also going to have to figure out, once we have this ourselves, we need, what are the best practices? Because I mean, again, this is software, so there's lessons from cybersecurity, right? So penetration testing, all of the things that you have to do to secure software, you have to do for this software as well, right? So but then it's a lot more, because what's the training data? Can I inject backdoors into the training data, right? So, and so on and so forth.
So I've been enjoying this conversation tremendously, by the way. I have one last question. If there's a thing, I'll ask both sides of it. Is there a thing that you worry about with regard to this technology? And is there a thing that you're looking forward to in terms of this technology? I mean, where do you think is where are the places where there is real possibility for harm, and where are there just fantastic opportunities for us?
I think for me, basically, we assume right now, I think the working assumption is all actors are reasonable, but that may no longer hold, right? So in a world where it might be possible to build custom models, you might have really malicious actors, maybe even state-sponsored malicious actors. So that's a worry, and we're still in the early days in terms of what can be done. So right now it's mostly language models, which is text in, text out. But obviously we're seeing text in, images out. But yeah, who knows, right? So by the way, I advise a startup that does speech synthesis real time, right? So in this Zoom, they can make me sound like Morgan Freeman in real time. So with minimal training data, right? So, but right now that technology is in their hands, but we're talking, I don't know, months before that's in the open source, right? So maybe not, maybe a year or two. The real time aspect is tricky, but.
Yeah, I would say I've talked a little bit about some of the things that worry me, and I think in particular these kind of emergent behaviors where once you reach a certain scale, like you know, it can, these types of like large language models, for instance, can appear to suddenly have like a theory of mind where they understand, you know, they have some ability to predict what the human judge is going to like and not like. So that kind of deception stuff is what I'm most worried about. I mean, I guess I would say it's hard to think about things I'm really excited about, which is surprising to even realize that once you ask the question. But I would say I'm excited about sort of some of the things that some of these like very large overparameterized models can do, like relative to sort of classical statistical inference. So I think there's like really interesting new results, you know, coming out from ML researchers who are trying to sort of probe the internal representations and realizing things like you can like, you know, swap the labels, like give some ML deep learning model like the wrong labels, like you have restaurant reviews and you switch like the good and the bad, and you can show that like sometimes in the early training layers of these models, like they actually learn the correct representation, so they can like almost undo certain perturbations in really interesting ways that I think, you know, maybe we can learn from, sort of as you know, they certainly go way beyond, you know, the way we've thought about statistical inference before. And there's other examples like that. So I guess I'm sort of excited about, you know, like these sort of emergent properties you get at very large scale, and also things like, you know, they can perfectly interpolate the training data and then still continue to improve. Like some of these latest results that like there's like the classical bias variance trade-off in statistics. Some of these overparameterized models seem to defy that. And so like, you know, the accuracy we can get is really impressive, and trying to understand this, I think, gives us a lot of new tools. But yeah, so there's, you know, both the scary parts, but also like the promise of really like better understanding inference in ways that we never imagined.
And
David, I'm going to give you the last word.
yeah, so for me, I know we're out of time, so I'll be very quick. So for fear, I think that the ELIZA effect, the tendency of people to ascribe much more understanding than the system actually has, could basically, if it was blindly followed, have enormous bad effects. But something that's really exciting is the potential ramifications for how this will at least interact with and perhaps alleviate some of the burdens of knowledge acquisition. It's not doing the same thing that a carefully crafted knowledge base will do, but it also could provide an alternative to a lot of inference processes. It could provide something that could be mined by other systems. And so basically getting that amazing breadth and potentially ways of retrieving things, indexing at a higher level of abstraction seems really exciting for leveraging existing AI techniques.
Awesome. I have to admit, for me, and I know we're at time. You know, people worry about the generation of untruth. I think that we are on the brink of being able to generate truth at scale, and I'm very excited about that. I want to thank everybody for joining us, and I in particular I want to thank the panel. This was a great conversation. We appreciate you being here, and really thanks to our audience. And with that, I will bid you adieu. Take care, everybody.
Thank you.
Thank you very much. Great conversation. Thank you.